Hi, my name is Richard Zhang, and this summer I got the opportunity to participate in the Chemical Engineering RU at the University of Florida. I had an absolutely amazing time at UF, but first let me tell you a little bit more about myself. So that's me. I'm an undergraduate student at Virginia Tech studying chemical engineering. At my home institution, I am conducting research in the field of nanoparticles and microfluidic device with Dr. Davis. I'm also conducting research in polymers in Dr. Fig's lab and work under the mentorship of Jared. I also participate in the design team at Virginia Tech called ChemiCube, where this year we are focusing on designing a direct air capture device. However, this summer I joined Dr. Zhang's lab in the Department of Pharmacy and worked under the mentorship of Zhang. In Dr. Zhang's lab, I learned about lipid nanoparticles, which have been shown to be a promising therapeutic. However, current lipid nanoparticles are inefficient at mRNA delivery. To improve lipid nanoparticles, we are altering one of the four main components of a nanoparticle, the ionizable lipid. We do this through the use of dendrimers, which are a type of polymer. There are many advantages to using dendrimers. Their properties are dependent on the structure, meaning that we can design them in a way to get favorable outcomes, such as high transfection rate and low toxicity. The terminal function groups of dendrimers are modified into lipids to produce unique ionizable lipids. These ionizable lipids are then used to produce dendrimer lipid nanoparticles. The formulation of these nanoparticles can either be done using a microfluidic device or rapid micropipette mixing. However, this is mainly dependent on how much nanoparticle you need to produce. So what was my role this summer? My project was to look at the mRNA encapsulation efficiency of the nanoparticles. This involved using ribogreen RNA reagent. To do this, a standard curve is plated for each reading. Each dendrimer lipid nanoparticle are plated 3 times and read on a microfluidic plate reader. From the plate reader, you'll get fluorescence reading like this. As you can see, there is a standard curve as well as 3 readings for each sample. The standard curve points are used to generate a line of best fit. Using this line of best fit in the fluorescence readings, you can determine the mRNA concentration. This concentration is actually the unencapsulated mRNA, but with some simple algebra, the amount of mRNA encapsulated can be calculated. Here's some data I collected plotted against transfection efficiency. We're still in the process of normalizing transfection data, so we do not have a complete analysis yet. However, once we do, we might gain more insight on how encapsulation efficiency plays a role in transfection efficiency. Overall, I had a great time and learned a lot of valuable research experience. So you may be wondering, what am I planning to do next? Well, this experience made me realize I want to go to graduate school, and I'm definitely considering University of Florida. There are so many fun things to do, cool places to see, and good food close by. Here are some of the pictures I took of this summer. I would like to thank UF for having me this summer, along with the Department of Chemical Engineering and the Department of Pharmacy. I would like to also thank NSF for funding this experiment. I could not have asked for a better summer. Thank you.